Alright, today we're going to be talking about ions, and what you need to know about ions are they're basically atoms, but they have a charge. And there's two types of ions we're going to be talking about. There's cations and anions. Cations are positively charged ions. That means they have more protons than electrons, and anions are negatively charged atoms, and they have more electrons than protons. Now, some students, they have a little bit of difficulty with trying to determine which one is which, and I find this to be very, very helpful. Just think that cations are positive. If you remember that, you're definitely going to remember that cations were going to have a positive charge.
Okay, so in order to get a better grip or handle on how to determine the charge of cations and anions, the first thing that we need to know is valence electrons. We touched on this briefly in Chapter 6 when we were talking about the periodic table, and when we get a little later in the lecture, we'll show you how the periodic table can be used to find the number of valence electrons. Alright, so a valence electron is an electron that is in the highest occupied energy level. And so what that means is after we arrange all of the electrons in their orbitals and energy levels and all that kind of stuff, the number of electrons that are in the outermost or highest energy level are the ones that are called the valence electrons. Okay, and the really cool thing about valence electrons is that they're actually the ones that determine most of the chemical properties for that element. Okay, and so that's why when we talked about groups and groups having similar chemical properties, the reason is because they have the same number of valence electrons, and we'll look at that in a second. So to determine the number of valence electrons in an atom, the only thing we need to do is look at the group number. All right, so when we made our periodic tables, we went through and we labeled the groups 1A, 2A, 3A, 3B, so on and so forth. All right, and valence electrons are actually the only electrons that are involved in chemical reactions. All right, so here are some electron dot structures for our group A elements, what we call the representative elements, and this is something that we'll be learning when we start getting into Chapter 9. Okay, but what electron dot structures show are the number of valence electrons in that atom. So you can see hydrogen, which is right over here, is in group 1A, and it has one valence electron represented by this dot right here. And you can see that lithium, sodium, and potassium, also in group 1A, have only one valence electron. And you can see through the rest of the periodic table, like here with carbon, which is in group 4A, has 4 dots surrounding it, and each of those 4 dots represents one of the valence electrons. And we can go even as far over here in 8A and talk about neon, which also has 8 valence electrons because it is in group 8A. Now, the only exception to this valence electron rule is helium. And helium is an exception because, if you remember, the very first energy level can only have a maximum of 2 valence electrons. So that's why helium only has 2 dots and not 8.
Alright, so every element, it wants to be as stable as possible, and in the universe, that's what everything tries to do. It's all based on stability. Things try to be as stable as possible. So if they're very reactive, they try to figure out a way to be unreactive and be stable. Now, on the periodic table, there's only one group of elements that are pretty much unreactive with everything, and that is group 8, the noble gases, because they have 8 valence electrons. And if you have 8 valence electrons, we call that the octet rule, because that's what every element wants to have, 8 valence electrons in its outermost energy levels. So, just as a reminder, an ion is just an atom with a charge, and what cations do is they are going to lose electrons, become positively charged, and have the same electron configuration as a noble gas just before it. An anion is going to gain an electron and become negatively charged. All right. Here's an example of a formation of a sodium ion. What happens is sodium, it loses its 1 valence electrons. So when you take a look at its electron configuration, its outermost electron is 3s1. It loses that 3s1 electron, and what happens is it has the electron configuration of neon, which ends in 2p6. And since it's going to have more protons then electrons now. So now it has 11 protons and now 10 electrons. It's going to have a +1 charge. You can either put a +1, all right, or you can have a 1 plus. They both mean the same thing. Okay, as you see down there at the bottom, if you have 11 protons and 10 electrons, that gives you with a total of a +1 charge. All right, here's just an example of what we just said. With sodium losing its 3s1 electron in its outermost energy level, what happens is it loses its electron and now it becomes stable because it now ends in 2p6, and that is the octet right there, those 8 valence electrons in the 2s2 and the 2p6. Okay, some trends that you need to know about the periodic table is in all group 2 elements, they are going to form a +2 charge. All group 3 elements, they're going to lose 3 electrons and they're going to form a +3 charge. We didn't mention is group 1 that will form a +1 charge. All right, we're going to go ahead and try to label that on our periodic table. So remember, group 1 is called the alkali metals, and they are going to have a +1 charge. Okay, all of group 2, which is the alkaline earth metals, they have a 2+ or a +2 charge. That means they lose 2 electrons. And all the way over on the other side by boron, which is group 3a, they lose 3 electrons, forming a +3 charge. Okay.
All right, one thing that we're going to talk about in the next lesson when we talk about writing formulas for ionic compounds, one thing that we're going to need to know is that everything in purple right here, okay, which are the transition metals, okay, you labeled that on your periodic table in chapter 6. These transition metals, except for aluminum, cadmium, zinc, and silver, will all have multiple charges. Okay, so for example, iron right here, element number 26, can have either a 2+ charge or a 3+ charge. Okay, and that goes for a lot of these elements right here in the transition metals. They'll have multiple charges. Some of them will be +2 and +4. Some of them will be +1 and +2. Okay, and then also what we need to talk about here is in group 4, these elements can actually have either a +4 charge, or some of them can even have a -4 charge.
It just depends if it's going to be a metal or if the element is a non-metal.
Right, so if it acts like a metal, it's going to have a +4 charge, and if it's behaving like a non-metal, it'll have a -4 charge.
All right, now let's talk about anions. So remember, anions, those are negatively charged atoms, and that means they've gained some type of, or gained 1 or more electrons, so they have an overall negative charge. And and the thing about anions is they too want to have stable electron configuration structures. So what they do is they look for the closest noble gas, and they're going to gain that many electrons to end in that P6 configuration. So let's take a look at an example of chlorine. All right, so chlorine, if you look right down its electron configuration, it ends in 3p5. So, and if you count the outermost electrons, the valence ones right there, you have 3s2, so there's 2 right there, and 3p5, which is 5. So that's, when you add them up, that gives you 7. It's 1 electron away from being the closest noble gas, which is argon. All right, so that's what chlorine is going to do. It's going to pick up 1 electron to become stable. And now what do we mean by stable? If we think about chlorine, the element chlorine, it is a nasty green toxic gas, and it's poisonous to us. It's very deadly to humans, and it could actually pretty much kill you.
Yeah, the use of chlorine gas actually dates back to World War I, where it was one of the original chemical weapons that was used on soldiers fighting in the trenches. So it's a nasty thing. What it actually does is it combines with the water that's in your body, and forms hydrochloric acid. And that hydrochloric acid starts to eat away at all of your lung tissues and your soft tissues inside your body. So it's pretty nasty stuff.
Very nasty stuff. And if you think about what's the difference between chlorine and chloride, which we're going to talk about naming in just a moment, which is this Cl with a -1 charge right here, the only difference is it just added an electron, and that electron makes the world of difference because that chloride is in table salt, and we don't die from table salt unless you eat too much of it.
No, it's pretty awesome, actually. We need table salt to survive. So by gaining 1 electron, we take something that's really nasty to human beings, and we turn it into something that is actually very beneficial and an essential part of our lives.
Okay. All right, so there's some trends also we can write down on our periodic table. With group 7, what you need to know is they're just going to gain 1 electron. They're going to form a -1 charge. Group 6 is going to gain 2 electrons, forming a -2 charge. And group 5, which includes nitrogen and phosphorus, they're going to gain 3 electrons, forming a -3 charge. So go ahead and make sure you label that on your periodic table.
Okay, and we're actually going to do that right now. So if you remember, we've already labeled group 1 as the 1+, group 2 as the 2+, group 3 as the 3+, group 4 as a 4+ if it is behaving like a metal, and then 4- then if it's behaving like a nonmetal. And then we were just talking about before, group 7, which is right over here starting with fluorine, they're going to be a 1- charge. Group 6, including oxygen and sulfur, will be a 2-. And group 5, including nitrogen and phosphorus, will be a 3-. Okay, and the very last thing that we're going to talk about here with the periodic table and the trends that we see is this group right over here, the noble gases. And as we've said before, the noble gases have 8 valence electrons already. They're stable. They don't want to lose, they don't want to gain. They're happy just the way they are. And if they don't lose or gain electrons, they're going to have a 0 charge.
And just one thing, Mr. Kleinschmidt, he's labeling his charges as 1-, 2-, 3-, 3+, 2+, 1+. That doesn't matter if you write +1, +2. So both of those ways are both correct. So it doesn't really matter. Whatever you prefer, they both mean the same thing. So if you have +3, 3-, they both mean the same thing.
So I just did it again. I'm used to writing.
It's really
it's a
big.
big eraser.
That's a very big eraser.
Oh no.
Oh boy.
Oh man.
Uh-oh.
It's okay. Then I think they know what we're talking about. So this could be -2.
There you go.
This could be -1. So either,
Bueno.
like Mr. Herzog said, either way is acceptable. Really just depends on who our professor was in college, actually. So
that's basically it. All right. So let's take a look at this. What I want you to do is try this on your own. So go ahead and take a look at the following elements and try to draw the Lewis dot structures around them. Keep in mind how many valence electrons there are. Remember, you just look at the group number to do that. All right, and then for the bottom part, so part 2, it says predict what charge and how many electrons will be gained or lost. So you have a noble gas configuration. Try to figure out what charge they would have. So for A, you're looking at potassium. For B, you're looking at nitrogen. And for C, you're looking at fluorine. So go ahead and try to guess what type of charge those elements are going to have.
Okay, and then what we're going to do tomorrow is you're going to bring this back in, and as a class, we're going to talk about what you got for these answers. So make sure you're prepared for class tomorrow morning. We'll have a question and answer session that'll take about 5 or 10 minutes, and we'll do that with each one of these lectures that we do. So once again, make sure that you have this completed for class tomorrow. We'll take the first 5 or 10 minutes after bell work to talk about any questions that you have and to answer the try this section. Thanks for listening, and if you have any questions, remember to bring them to class tomorrow.